Welcome to Composite Hybrids by Shehzad and Prarthana. Sydney Olympic Park, as part of the Greater Parramatta to Olympic Peninsula, is identified as a strategically located area offering rich cluster of metropolitan attractions, extensive sporting and recreational facilities, and open public spaces. The maturing parklands will become Sydney's great green lung, playing an increasingly important role in the city's recreational and environmental life. The project site, Kronos Hills and Wentworth Commons, contain remediated landfills, freshwater wetlands, frog ponds and underpasses, providing a primary habitat for the endangered fauna species. Furthermore, with its large open recreational spaces, it provides ample facilities for all ages for public leisure and play activities, including public art pieces, walking and bike trails, and a children's playground. The site is affected by primary issues like destruction of natural reserves and ecosystems due to rising sea levels from increasing rainfall averages, detrimental environmental effects on humans, flora and fauna caused by contamination to land from naturally occurring sulfides and to groundwater system from leachate precipitations. Aside from environmental issues to consider, we will also be looking into developing a precinct that can accommodate the significant increase in demand for more facilities and amenities to address the current amenities under high duress from fast developing neighborhood communities and increased visitor rates. We investigated two case studies related to our primary issues with water, how rainwater can be harvested and utilized in cooling, irrigation, and landscape design. The other case study of the Art Center project explores opportunities with an unused remediated land site in China that has been transformed into a public venue through clever integration of the architectural structure with the contaminated landmass through minimal structural points of contact with the ground. Site development aims to address and meet the key targets for the UN sustainability goals of climate action, clean water and sanitation, life below water, and affordable and clean energy. The key targets we will aim to achieve are: take significant action against degradation of natural habitats, halt the loss of biodiversity, and protect and prevent the extinction of threatened species. Furthermore, protect and restore water-related ecosystems like wetlands and creeks, include water harvesting, desalination, supply of fresh water, and educating communities on water management.
Script 1 explores the tectonic form and draws inspiration from spiderwebs and climbing frames, and Prioto's exploration of use of lightweight, tensile, and membrane structures. It works on a rule-based system of selecting minimal points of contact and elevating structures above ground at different volumes and scales for humans, flora and fauna habitations. The script is driven by three main conditions: minimal points, jitter frames, and bug volumes. Script 2 explores the project's synthetic nature by Vlad Tenin, which is a collection of prototypes that involve nature-inspired algorithm, mathematical relationships, and geometrical constraints, creating morphological design species that explore spatial quality, materials, and volumetric intricacy.
We are interested in exploring futuristic construction and material technologies like automated fabrications through programmed robots using composites involving dynamic materials responding to climate changes and flexible materials like synthetic fibers. An example of composite material exploration being looking into harvesting sea salt from the increase in sea levels and encasing it over locally sourced recycled steel members. Exploration also includes potential panel inset options with flexible metals like thermo-bimetal products or solar panel insets to address heat reduction and energy harvesting issues. We will further explore these processes in terms of providing future-proofing solutions to adapt construction technologies to the climate change problems. Choosing a section of the site that exhibits varied elevations of remediated lands, significant flora species, and frog ponds with human walking and bike trails crisscrossing, these site considerations led to the conditions that drive the script development. Condition 1 is minimal points, exploring creating structures over remediated lands at varied elevations through picking certain safe anchor points. Condition 2, jittered frame. Explore creating a matrix of 3D connected points based on existing trees and existing site urban elements that allows traversable spaces at human scale and at more concentrated junction spaces for both flora and fauna to inhabit. Condition 3, bug volumes. explore creating a collection of interconnected volumes that allows for building enclosed spaces for inhabitation at varied scales for both humans and flora and fauna. These are the iterations derived from the base model, exploring various anchor points, various scales of enclosed space volumes, and varied z-value heights of points based on graph mappers that calculates fall according to water flow directions, producing iterations efficient for rainwater harvest. Views showing mutual habitation of the structure by humans, flora, and fauna, as well as a potential scheme of rainwater harvesting and redirecting the harvested fresh water into wetlands or frog ponds.
Minimal surfaces are those that have a minimal total surface area given the volume. The most common example of minimal surface is a soap bubble formed between monobore loops. The base unit selected for form exploration is the shown sparkling minimal surface. The best way to reconstruct this unit for a better understanding is to think of it as a minimal surface made from three loops tabbed perpendicular to each other around a strip. The other way to reconstruct this unit is to imagine it by extending the handles towards the vertices of the construction cube to form a sphere. A triply periodic surface, or in simple words the one we have at hand, offers a great scope in generating a wide range of forms that are rich in spatial quality and volumetric intricacy. The base unit for form exploration is built in a cube with control points based on one of the faces of the cube. Since the base form is built by mirroring one single surface along radial planes, changing any parameter will result in uniform change throughout. As the next step in generative design process, resulting iteration is mirrored along two adjacent faces of the construction cube. A simple box array was avoided. Surfaces were trimmed out at different points using basic geometries like sphere and cube.
The two scripts come together to perform like a hybrid structure, offering amenities at human-centric scale as well as flora and fauna scale. Script 2 will create the human-centric stereotomic forms according to function and habitation requirements. At a smaller scale, Script 2 will provide art installations and street urban elements. Script 1 will act as the tectonic structure connecting the main function zones as well as providing environmental concept solutions for rainwater harvesting, hosting fauna and flora habitats, and shading exposed walking and bike trails from direct heat. There will be four key human-centric structures in our precinct concept. Starting at the Discovery Center, visitors can hire a bike and journey through the canopy structures to the water management pavilions and flora and fauna management pavilions, where they can learn all about the environmental strategies in play. The visitor then reaches the leisure and play zone at Wentworth Commons, where they can relax, enjoy new public amenities like open-air cinemas and amphitheater spaces. The journey then ends by continuing on the bike path as it winds back to the Discovery Center, providing the community a unique amenity to explore with a very particular experience. These are two photomontage views of our concept direction. The first view visualizes a potential form for the Discovery Center, and the second view shows the structures adapting to water level increase by creating elevated walking and bike trails as new species start to inhabit the structures below.
The meta drawing presented here depicts various threats the Sydney Olympic Park is subjected to and also depicts the scope of our designer in a symbolic way.
At a more detailed concept exploration, our scripts aim to address the rising heat issues and concerns of prolonged heat waves through looking at options for panel insets, with script 1 providing different levels of heat and light transfer as well as opportunities of energy harvest. Script 2 modules provide opportunity as enclosure elements that can diffuse heat transfer through the structure according to the module scale and void configurations. The scripts jointly offer potential opportunities in construction for on-site 3D robotic construction or prefabricated modules that are transported to site by drones. There are also iterations that we can create as joinery elements and load-bearing elements at various scales according to different wind load pressures. This will be further explored in phase 2.